Hey, pause.
Hey, evening, sir.
Hmm. Good afternoon. Good night. Good night.
Hi, Carol. Has anyone heard from Asia?
Yes, sir. She said she won't be at class to excuse her absence.
Mhm. All right, so let's begin then, because Mikey is running a little late. We didn't want to start with just one. Um, so let me just get going. All right, so I hope you remember what it is that we did last time around. We um, looked at our structures. Tonight, I want us to spend a bit of time, not the whole last time. Oh, Mikey's here now. I don't want to spend the duration of the class time on.
Good evening, sir.
Hi, how you do? I don't want.
Good,
I
good.
don't want. Good, good. I don't want to spend the whole time on on some formula writing because I need to show you one or two quick calculations. I don't want to spend a lot of time on the formula writing because there are some other little areas that we need to worry about, and I want to move on. All right. So what I'm doing here, students, most of you didn't do the chemistry before, and I'm thinking that you are getting the hang of it. I'm spending a little bit more time on this because this is what you necessarily can't read to understand on your own. When I get into the lithosphere, the hydrosphere, and the asthenosphere, the different spheres, you're going to have lots of reading to do on your own. And those readings will pretty much be used to make up the time that I'm spending here. I don't want to rush through this because I'm teaching students who have not done chemistry before, and it's a small group of you, and I don't expect you to do the things and fail. So forgive me for the pace at which I'm going. Uh, I will, however, speed up when I get to my spheres, and I'm getting there pretty soon. Pretty soon. Remember, this is your final semester. We don't want any hiccups so that you feel anything, so that you can't graduate or complete your course of studies now. I know some of you may have to do your work experience at other times. I don't know. I'm really hoping you can get it done up this semester so that come next semester, your summer semester, you're free as a bird. But if not, at least you know that you'll finish your courses. All right. So with that said, let us go. Um, I want to look at some formula writing. Now, before I do that, I'm going to give you what I would call a great piece of homework, looking at the periodic table. And in particular, I will be asking you to do some activities with the periodic table. And let me just share this. I've not yet verbalized all my thoughts with what it is that I want of you. But in a nutshell, I'm going to be asking you to draw the structures of the first 20 elements of the periodic table, identify the name of the element, um, the atomic number, the proton number, the number of electrons, and the electronic configuration. There's some other stuff that I'm going to put here as well. But in essence, this is what I want you to do for me. Yes, you're going to do it on paper, and then you're going to scan those and send off to me so that I can have those. This is going to be maybe about no more than 5% of your final grade. Um, so it could be 2.5, it could be 3, it could be 4, it could be 1, it could be 2, it could be 5. Um, I am still in the mood of working on the percentages for the coursework pieces. But if you follow me and you do the coursework pieces, you should be fine. All right. You're also going to be getting lots of writing. This course really involves lots of writing. And also, maybe don't write well. Or let me just put that plug. Is it any one of Uno? When I give you my work to do, I'm going to ask AI to do it. And I run my stuff. And it tells me that there's plagiarism. And I'm going to say nothing. I just going to use 0. And I mean it. You're getting 0 for the work. 0. And I'm not going to give you no opportunity to get no other piece to substitute for that. Let me tell you what it is, how important this is, students. When we send graduates out, we want to send qualified people. A whole host of students some years ago failed a particular course because some students believe that teachers are kunumonos, that we don't know where it is that you're going to get the stuff. And I won't tell you how it is that we are able to identify the stuff, because I don't want you guys to say, oh, sir, they said this, so again, not do that. And they were identified. And a whole host of students failed. Out of maybe about close to 100 students, it's less than 20 students who pass the course because they cheated. They cheated. So I was telling you from now, when I give you your writing pieces, don't think that you can do a writing piece and tell Mr. AI to, hey, do that piece for me, yeah? Because we not pay Mr. Shan no mind. And then now, when Mr. Shan go do something and do the thing, you expect to get 20 out of 20, and when you get 0 out of 20 or 10 out of 20, you start complaining. It's not going to help you in the final exam. All right? Go and research your stuff, do your proper quotations. You're doing an academic piece of work. All right? And my stipulations are clear, you know. When I give you a writing piece, you must use a minimum of, say, 5 or 7 references, nothing later than 2020 or 2023, because I want current information. So I have my stipulations to get you to do the work. So, and I need my references, my APA format. If it does not follow the rules and the stuff, you know, marks will be taken up. This is an academic writing that you're going to be doing. So I expect you to write accordingly, just to see. All right. So what I want to do tonight is to spend a little time, just even though I know I'm giving it for homework, but I need to spend a little time going through the first 20 elements of the periodic table, just talking through a little bit about it. And then, as I said before, you are going to be reading widely to get more information. So the first 20 elements of the periodic table, we have so we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then we move down to sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. All right, those are the first 20 elements of the periodic table. You must know not just the mass number, you must know the atomic number, the proton number, and the number of electrons. There are 4 things that you must know out of your headspace. All right. So, for example, we're talking about magnesium. We're not going to talk about 24.305. We're going to talk about 24. All right. Then we're talking about potassium. We're not going to talk about 39 point. We're going to call it 39. We talk about calcium. We're not going to talk about 40.078. We're calling it 40. All right. So we're using the whole numbers. All right. Aluminum is 27. Silicon is 28. Right. Phosphorus is 31. Sulfur is 32. Chlorine is 35.5, not 45, 35.5. Argon is going to be 40, right? Calcium is going to be 40 as well. Potassium is going to be, you know what that is. So we're using the whole numbers, all right? And then you know that the atomic number is going to be equals to the number of protons. It's also going to be telling you the position of the atoms in the periodic table. In group 1, we have all the metals. All the metals, the reactive metals, are in group 1. All right. And if you look here, you see they call alkali metals. It's alkali metals. So hydrogen is kind of special. Let me tell you how special it is. Sometimes on the periodic table, you might find hydrogen over here. Sometimes you might find hydrogen over here. So, all right. So hydrogen is very special. It says it's reactive nonmetals. So the reactive nonmetals are placed in green, the reactive nonmetals, right? You see that one here? That one is kind of special. That's it in a blue. We soon talk about him. So these are the alkali metals. Alkali metals are very reactive. You see, if you get a strip of sodium and you spray some water on it, I won't even tell you what may happen to it because I don't want to go try it and go hurt yourself. But it reacts explosively.
It's gonna explode. It's gonna
Yes,
explode.
man. Yes, man.
I did it already.
Explosively. You did it already?
Yeah, it's not pretty.
Oh, are you still alive? Thank you, Jesus. So it reacts explosively, and one has to be very careful. Lithium is also very reactive. Now, just some general trends. I'm just talking to you about the periodic table. In a quick overview, as you go down the group, these become more reactive. So potassium is more reactive than sodium, which is more reactive than lithium, right? So the reactivity increases as you go down the group, right? The reactivity increases as you go down the group. And I'm going to show you why. I'm going to show you why in a quick nutshell. Where am I, Lord? Where am I? Draw. This is where, oh no. Now, hope you paying attention to what is happening here. 2, 8, 8, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and we have 1. All right. So what it is that I have here is lithium, sodium, potassium. Look here. Lithium, sodium, potassium. The attraction of this valence electron to the nucleus is greater than the attraction of this electron to the nucleus, which is greater than the attraction of this electron to the nucleus. Tell me why.
The distance between the nucleus and each energy ring.
Very good. Very good. So think about it. Paz have him little girlfriend. When she's in Jamaica, him see her every day. And him and her move good. Thick as thieves. Paz little girlfriend now get on to work. A foreign. And then now for the first 2 months, them a talk and a talk every day, video call, lunchtime and so forth and so on. And then now, all of a sudden, it starts to snow. She gets distracted because she can't go outside on her lunch break now to go and make the telephone call. She can't use her cell phone on the inside. By the time she reach home, the time zone makes it difficult because by the time she reach home and she call in pass, she can't get through to pass. And then now what happened now, there's a strained relation until there's nothing more that is happening because of the distance. So the distance between this valence electron and the nucleus is too great. So the attraction, the force that holds this electron to the nucleus is going to be less than that holds this one to the nucleus. And of course, this one is going to be stronger. So therefore, potassium will readily give up this one electron out here quicker than sodium, quicker than lithium. Can you see that?
Yes, sir.
Yeah, come on. Because the force required, the energy required to break apart this one electron is going to be so less because the attraction is not, it's there, but it is so far that this lithium here has a greater attraction. So as you descend the group, the reactivity gets even faster. It's a rubidium, caesium, and francium. Francium is the most reactive in the alkali metals because this valence electron now, when it reach down here, so think about it, it is 87. So the distance of that one valence electron to the nucleus is almost negligible. So guess what? I want to say, here the plan. Me feel like one stepchild here, I'm gone. So the earliest opportunity that valence electron gets to go is going to go. So this is more reactive than this, and so the reactivity increases as you descend the group. Does that make any sense?
Yes, sir.
All right, good. And then
Sir,
no.
and does reactivity necessarily mean so reactivity means losing an electron
How
like
easily
easily.
it gives up that one electron for a reaction, for a chemical reaction.
Yeah, because the connection to the nucleus is not as strong as one that is closer.
Yeah.
Okay.
Now, if you look at my alkaline earth metals, these are called earth metals because they are found within the earth's crust. And you will see a little bit more now when we start looking at stuff. So, that, when I go to the field, only time I go to the field and find calcium. Matter of fact, when I taught you geology, well, I think I taught you geology. Anyway, you would have had, Mr. Waldo would have shown you, we'll call it now.
You taught us.
Okay, I taught you. Well, I guess I would have shown you what calcium looks like or what calcite looks like and what, quartz look like, so forth and so on. So, when you go out into the field, sometimes you see fractures in exposure and then you see some crystal looking sort of things that are from. I say, blow, whoa, I find diamond. No, the quartz has way too many fractures to it that you can't mix up quartz with diamond. Diamond is very special, right? But the calcium now is what we find very often, and I'm going to tell you why. Because it is found within the Earth's crust. I have a friend who lives up Mavis Bank, and literally the river runs behind his house. And because you have natural springs up there, the water flows and it is channeled into the Mona Reservoir. Now, as the water travels, it is picking up all of these alkaline earth metals. And all of these, and then the water becomes hard. And all of what I'm saying to you here now, which is why I have to do this before I move into the hydrosphere and the lithosphere, because all of this is going to come back and we say, oh, sir, I'm seeing the connection. Life is just one big cycle. One big cycle. All right? So the water now becomes hard because the rainwater is soft water. yes, we know that because of the constant burning and because of the exhaust that gets up into the atmosphere, the acidity is increasing because you have more carbon dioxide up there, which is CO2. These are things that we did last time. CO2 is going to be a covalent bond. But because the CO2, now we have so much CO2 in the atmosphere, when it rains, the CO2 is reacting with the H2O to form a weak carbonic acid. All right. Now, when you go to places like China, for argument's sake, back then, I think their air quality now has improved, and particularly so during COVID because lots of restrictions took place. So a lot of people weren't driving. So I'm going to tell you, the environment can repair itself. All right. So if you give the environment a break, it will repair itself. So for example, why do we ask people not to burn? We don't want it to burn because the depletion of the ozone layer is a contributor cause to this greenhouse effect, and because of certain gases. Now, if we stop the burning and we stop doing some of the things that contribute to these greenhouse gases, it means that, okay, there is no more production of these dangerous gases that are causing the depletion of the ozone layer. So guess what? The ozone layer starts to heal itself. And in repairing itself now, we are we are sheltered. The ozone layer is like a big umbrella. And when I get to the asthenosphere, you're going to see what I'm talking about. It's a big umbrella. And guys, you will have a greater appreciation, hopefully, when we go through all of this, how important it is to take care of the environment. How very important it is for us to take care of the environment, right? So let's go back to the water that is being channeled from our catchment areas into the reservoirs. So as it moves, it is picking up um, these carbonates, magnesium carbonate, calcium carbonate, um, and and God forbids if we use these fertilizers. And again, that's why we go natural. So we don't want to use these acidic fertilizers, especially one that contains sulfate, because what may end up happening is that you have the magnesium sulfates that are being formed and the calcium sulfates that are being formed. You don't want that to happen. So how we know, and then no, because of the rainwater that comes, the rainwater is really soft water. And then because it's channeling through the crust, the Earth's crust, because sometimes some of these water sources literally come through one or two rocks, talk truth. Anybody did know that?
Because the rocks are poorer.
Yeah. And if for example, Dunn's River, Dunn's River is a beautiful place. Disappointed that I was told by a reliable source that someone went there recently, and at the foot of the falls where lots of people who can't climb the falls will just stay there and just allow the water to beat on them, therapeutic sort of massaging, hydro massaging. I'm hearing that people can't stand there again because of how deep it is. The erosion that took place. That's the point I'm making. So it is like you're out at deep sea. Anybody hear what I said a while ago?
Yes, sir.
Yes.
All right. Let me ask you, as an environmentalist, how would you repair that? I want you to think about it. So if you're following the conversation that I'm having, and I'm saying to you that at the foot of the falls, people can't stand there again because it is so deep. Not talking about waist high now, it is getting to shoulder and submerging some people, right? So, or some people are submerged in it because of how deep it is. How can that be repaired? Let me hear how well you're thinking. Oh, mosquitoes in here. How well you guys are thinking. Talk to me. What can be done?
All right. So, sir, I am not familiar with how the fall is because I've never been there, sadly. But I would um either like plant enough semi-aquatic plants along that area to hold the soil together and absorb as much water as possible.
Okay. And I think maybe you said that because of you not seeing the air, but the area is you have the falls coming down, so there's a part where the fresh water meets the sea salt water. So it's one open space. So yes, if you do aquatic planting or plant you know aquatic plants, plants that can really take water, it won't rot the roots, etc., etc. It may, because of the constant movement, patrons may trample on it. So that in and of itself may not work. But think about it, man, because there is another remedy that immediately I was able to say, okay, as
Can I use
a
boulder?
very good, excellent. So we're getting closer now. So we use boulders and do what?
Seawall? Like a seawall?
Is it seawall? Talk to me. Boulders and what?
So sir, you're thinking of putting up a barrier, like a groin, to reduce the movement of the sediments that are suspended?
That could work as well. Maybe that could work. A combination of what you and Paz have said could work. Karen, we need for you to come in. And let me tell you why I like the idea of the groin. I also like the idea of using boulders too. But you can, of course, use the boulders in groins. The groin now will can give it a tiered effect, so to speak. You understand what I mean by tiered? Like you have a step?
No.
Yes,
Oh,
sir.
oh,
Yes, sir.
yeah.
Yes.
Yeah, man, like you have a step.
Sorry, you know what? I would. So knowing that you have that level of erosion, I would use technology and have some self-assembling structures that would mimic the flow of the water and redirect those sediments suspended in the sand, in the water, back to the falls and have them redeposited and provide some stability in restoring that. That's the new thing right now, but it's very expensive to do.
Which is what I'm gonna say. Which is what I was gonna say to you.
The expense.
Because the technology is there, but the technology is there, but it is exclusionary. Many countries will not be able to afford that level of technology. But I will come back to the technology though to show you how I would use it. What I would do, Carrie, let me hear what you are saying. I hear from Paz and Mikey. Let me hear what
Sir, I was going to say the same thing that Paz said. I was going to say to like use like big rocks and like put them into the water, but I wasn't going to say boulder. I said rocks. Paz said boulder.
All right. So let me tell you why I have an issue with just the raw boulders like that. Because it means that when the patrons now of the beach are walking, because the rocks are not there are going to be gaps between those rocks. While you're walking in the water, they can slip because it's going to get slippery at some point in time. They can slip and their feet can get stuck and they can actually, fall and they can drown and they can die. Well, if they're drowned, they're going to die. They can fall, they can hurt themselves, they can break a limb because their legs can get stuck in there. Paz, where's work for you again?
Airport.
Good. So every day you travel down Palisades, don't it?
Well, not every day, but yeah, practically.
I mean, airport to work on it every day you can work?
No, sir, no work shift.
Oh, great for you. Beg your work, no? All right. So So when you're traveling to work and you look to your left, those boulders that were placed there is to prevent tsunamis and heavy wind, to cover the main road. Because in our recent past, whenever we have hurricanes, I know we have hurricanes September go right down to November, October, right? And like last year, the heavy rain started from the ending part of August. So and then again, last year was a very active year. So when we have lots of rains, heavy hurricanes, um, the sea water break its riverbank, and you have the water moving from one side to the next, depositing lots of sand, siltation on the roadways. Um, they would have to now go and scrape the sand from the roadways. In so doing, it causes potholes, and it is very expensive now to go and asphalt that whole area. So a solution to it, which is a very good solution, um, is to put those boulders. So what they did, they would have, you know, purchase, and I think this is where they got it from. Anybody who knows Bayside in Portmore with the limestone exposure right down there, so you know, they would have gotten big boulders from there. Persons would have sold the government boulders from their plot of land, and these boulders were strategically placed, right? To break the water. So when the water comes there, it breaks it. So what happens now? People do climb on it, but one has to be very careful, because it does not tessellate. Tessellate means that every gap is filled. It's not like a puzzle where, when you put one piece and connect it correctly to the other piece, there's no gap. There are gaps inside there, and people have to be careful, because you may be climbing slip and your leg gets stuck and you can break that limb. So what I would do particularly is to build groins, and I would build tiered groins, where you can literally climb like a step. And because the groins now will be flat, it will be flattened. All right. So you may say, but sir, when you build a groin, you're going to have wire, and in the wire, you will have these boulders. Yeah, I agree. Or you may have these conglomerates of maybe sandstone, sea stone, whatever it is. But what I will do is now use the technology that when these boulders are placed in at the foot of, or the base of the falls, I will then use the technology now to migrate sand from one area, so we can blow the sand now into these groins in the water, so that it can fill those gaps between those conglomerates, so it can almost have like a solid piece of
So
thing that you
like,
can stand on.
oh,
Sorry, I
like
think
in the
you're like an
crevices?
engineer and not an environmentalist. When I like that,
Say that again.
You're thinking more like an engineer and not as an
Uh,
environmentalist.
no,
I
but guess
don't
what?
like that.
Okay, why you say you don't like it? Because I'm
Because
migrating this. Because you say I'm
no, because
migrating sand.
that's one issue.
Uh-huh.
The other issue is introducing a structure that
Mm-hmm.
naturally would not be present. And that's why my first go-to plant was to plant up the area, whether with some form of marshy grass or even along the banks like mangroves. Because what these structures, these plants will do there.
No. Hold on. Before you go there, press pause. Press pause. Mangroves take years to grow. When I say years to grow, years to grow. And when you plant mangroves, it's now going to be a haven for crocodiles. It's going to be a haven for all these other stuff. So it means now that you're going to lose the essence of what Dunn's River is. The truth of the matter is, as an environmentalist, the environment needs to rest. So at times, Dunn's River is supposed to close and say, yo, the area needs to breathe. So what you don't want to do is allow it to be open and you have further erosion. So what it is that you need to do is to mend what it is, to mitigate against further erosion. So yes, you're going to be introducing something that is foreign, but when you introduce something that is foreign now, because already what is happening, is that you're having displacement of sand from the area. It now becomes a hazard, because when people go there and say, oh, I can't go and stand up, they underestimate the depth of it, and they may find themselves into problems. So what it is, you're migrating sand from one area of the beach itself to fill another area. And then now when you hear me talk about the hydrosphere, we will see now how you can have more production of sand from the inner courts out to sea, right? Because if we kill these coral reefs, then what we're gonna have? We're not gonna have the production of these things that's coming up. But you're migrating something, you're migrating sand from one area of the beach to another area is really not damaging the environment per se. Yes, I understand that you're introducing something that is foreign, but this is something that you're doing to mitigate a situation that is already going bad. And if you don't put corrective measures in there, you are going to lose it. So it is something that must be done. And surprisingly, the UDC has not contacted the university or the technocrats to go and amend the area, because it's one of our natural habitats. And as I said before, the environment needs an opportunity to breathe, right? But why I went there though, you and I are not allowed to a certain point up that falls. So when you get to a particular point, that is the exit. And when you get to a particular point, it's as if the water is still. It's as if no water is flowing, because the source of that fault is just literally one little hole. But because it's descending, it picks up momentum, kinetic energy, and the water starts to flow and starts to gush. All right? Now, and it is a continuous flow. Now, that flow also go elsewhere, because Margaritaville, Lobster Dave, between Margaritaville and Lobster Dave, there is also an underground channel, freshwater meeting seawater again, right? And then over that side, it's not island, but over that side you have lots of freshwater fish in a natural habitat. And sometimes these fish get trapped and somewhat escape into the saltwater area. Do you think that they can survive in the saltwater, the freshwater fish?
No.
No, sir, not at all.
They will die, right? So again, we're going to talk about that, the concentration, what happens, all of that. So yeah, so the point I'm making there is that it picks up lots of carbonate. So when you and I boil our water from in our kettle, when you and I use our shower heads, when you and I use our kitchen taps, when you and I go into the laundry room, or hoses outside, we recognize sometimes it has some lime scale. And people may say, oh, is the chlorine. And you ever heard anybody say that before?
Yes, sir.
But can I tell you, it's not the chlorine. It's a carbonate.
Yeah.
It's a carbonates. So if you have that buildup in your kettle, like I always do, and I mean, just before class, I had my cup of tea, as per usual. And it's fine, because when I was pouring the water from the kettle, I wasn't seeing any residue coming out. But every now and again, I decide that I'm going to put some vinegar in my kettle, and I put it on like I'm boiling water. And I increase the temperature of the vinegar because it increases the rate of the reaction. And I let it boil up, and I let it stay overnight. By the following morning, My kettle is brand new on the inside.
So it have no vinegar taste to it. Me no like the
No,
taste of
sir.
vinegar in it. No.
No, sir. It won't. It won't at all. Promise you. Because we don't
So,
wash it out there after.
so,
Go
so
ahead.
you just throw out the vinegar and that's it, like just put it on just catch normal water in it and swirl it around and throw it out.
Yeah, so you're going to wash out the kettle thereafter.
Okay.
Yeah, man. So you won't have any vinegar taste in it. I wouldn't want to drink vinegar either. But you're not going to have any vinegar taste in it, man. Trust me. So what it is that you're dissolving actually is the carbonates. So you're going to now get the carbonates out, because it will clump together. Of course, a new compound is formed, and you can get it out. You know where you can do that now too. I destroyed one of my steamers, and I need to replace it. I destroyed one of my steamers because I I used to get a gush of steam out of the steamer. Then I recognized one day we turn it on and you heard that it's on, and then the steam is not coming out, and then it automatically turns off because it was overheating. And I said to myself, okay, come on, apply a little bit of chemistry. So what I did was to put a little bit of vinegar in there, vinegar water. I diluted the vinegar, put it in there, heat it up a little, and then it started to steam. I was like, great. But apparently what happened is that the vinegar water wasn't finished, and we had a bit of vinegar water in it. And of course, it then reacted with the metal in there and caused corrosion. And because it corroded, there's no more steam that can come out. So technically, it mashed up. Bought another one, decided that I'm not going to put any vinegar in there, that I'm going to use deionized water. Deionized water is water that you would have taken out all the chlorine from it. All right? And all the carbonates would have come out as well. So I used the deionized water, but clearly it wasn't it's the same brand, it's the same make, but different model. Sorry, the same model, but different make. And that too died a natural death. So within a short period of time, I've gone through two steamers. The iron is also like that, but the iron is fine. Iron is different. If you use tap water in your iron for steaming, after a while, the steam is not going to come out. What you can do is just pour some vinegar in there and steam it to dissolve it. And of course, you're gonna, you're not going to put the raw vinegar. You can put a dilute solution of it, and then you can use your deionized water in it thereafter, so that you don't have that sort of lime scale build up on the inside. All right. So that's why we call it alkaline earth metals, because they are found within the Earth's crust. All right. Now, if you look now at boron, aluminum, silicon, gallium, and all those in blue, those are post-transition metals. Now, in the middle from 21 to 30, you're going to find your transition metals. Transition metals are so called because they move from one state to the next, and they have different colors, the same compound, and they have a color in this one, like chromium. Chromium you have, it's green, and then it can have a different color. With iron, it can have a different color. Cobalt have a different color. Copper, of course, you have that lot of reddish brown with the copper, but it can get even redder because of the oxidation. You have the zinc, titanium, is what Canada has that the United States need to purchase for their starting materials for many of their products, and stupid enough that they are imposing a 25% tariff. And smart Canada decides that, okay, two can play the game. So if you are imposing a 25% tariff, we are going to impose a 25% tariff. The nearest neighbors to Canada, of course, that the United States borders Canada, but the nearest states to Canada, their power comes from Canada, and it's about 19% of the United States power is out of Canada. And Canada says, hey, here's the plan. Instead of 19% there of us supplying energy to you, we're going to take it back. You guys are doing engineering geology now. I mean, not engineering geology, environmental engineering,
Yeah.
environmental engineering.
Yeah.
All right.
Yeah.
So I taught that course once. So I know you're going to do something like geothermal and different forms of energies. Have you started those yet?
No, no.
Okay, right. So different energy sources. So what they will now have to do is to find other sources, because it means now that their electricity bill is going to go up, because Canada is going to be charging a little bit more. Of course, a 25% tariff, right? So if the United, so but the shortfall is, yes, the United States, Canada provides about 19% of their energy to the United States, but the income that Canada gets supplies about 25% of their GDP, their gross domestic product. So their income is going to be reduced because of this tariff. And this is what Trump is trying to do, is to allow these other countries to, they are going to lose their GDP. So it means that some parts of they're not going to be able to afford some things, because their income is going to be reduced. But what Canada is saying, that we have other neighboring countries that we can sell our energy to, so it is, and we're not going to put a tariff on them, right? So they are finding other ways of recouping the lost 25% of their GDP by selling to other countries. All right. Now, and by extension, huh?
We are feeling it and them.
True.
You know,
And by
feel it already.
yeah, man. Oh, yeah. And by extension, what is going to happen too is that, remember that Canada is a part of the CARICOM, right? The United States is not a CARICOM member. The Caribbean are members of the CARICOM region, so chances are Canada can sell us their crude, right? Because we purchase crude from all over. So so the point is, it's going to be a nasty war. It's trade war. That's what I'm seeing, right? So these metals, titanium and nickel and zinc, cobalt, these have medicinal properties as well. All right. Cobalt is also used to treat some types of cancers, right? So these countries, Canada has a production, of all of these. So and again, it's transition, because you have different forms of it, that you can that they can exist in. If you look at the reactive non-metals, of course, your fluorine, chlorine, bromine, iodine, those are your group 7 metals, non-metals. And they are extremely reactive, because fluorine, chlorine, bromine, iodine in group 7, you may remember chlorine has 70 electrons in its outer shell. I remember, the group that they are in tells you how many electrons that they have in their outer shell, their valence electrons. So once they're in group 7, it means that they have 70 electrons in its outer shell. The similar explanation I gave to you with the group 1s, the alkali metals, as you descend the group, it gets more reactive. It's a similar situation you have here. But what is also important is that in group 7, the change state. So is fluorine a liquid, solid, or a gas? What do you think?
I guess.
Okay, what do you think of chlorine? Chlorine exists as a solid, a liquid, or a gas?
Fluorine.
Solid.
Liquid.
Solid.
Yeah.
Well,
Yes? Okay, good. And what do you think bromine is?
uh,
That's a gas.
No, man. It's a liquid.
Go
So let us
liquid.
look at the key over here. So C here is, so the black things are solids. Hg is going to be a liquid, like here, but bromine is also a liquid. It's the ones with the H, the, what do you call it? It's red color. Hydrogen is a gas, and that's why sometimes hydrogen is over here. So these here are gases. But guess what? This is a gas, this is a gas, this is a liquid, and then this is a solid. So look at the key. This color is representing gas. So this is a gas, this is a gas. The blue is representing a liquid. See here? Liquid. So mercury and bromine is a liquid. I ain't supposed to know that mercury is a liquid because you know they have it in our thermometers, eh? And then no bromine is a liquid. And then no iodine is a solid. See here? The black ones are representing solid. So let me ask you a question to see if you are thinking. If fluorine and chlorine are gases, bromine is a liquid, and iodine is a solid, what do you think astatine is?
Solid.
Why?
Because it's in a block and it's a fall apart where, yes, in a block.
All right, don't tell me that it's in that, because if I never point out this key to you, you wouldn't know. But tell me why you think that astatine must be a solid.
Hold on, it's in group 6.
7.
Group 7. Hmm.
Look at the change of state. Fluorine and chlorine are?
Gases.
Bromine is a?
Liquid.
Iodine is a?
Solid.
Solid.
So what do you expect astatine to be? And why? So you said solid, very good. Why?
Transition.
Remember, no, you remember astatine couldn't be a gas. Can you store a gas under solid?
No.
No.
The gas would escape, don't?
Yeah.
And if you have a liquid under there, could you have a solid on top of a liquid?
Nope.
No. So this also has to be a solid. So it goes by extension that astatine has to be a solid. So when you look at the trends in the periodic table, you can figure out some stuff.
And it look heavier too.
And it is definitely heavier.
So the heavier ones them tend to be solid.
Yeah, very good observation too. Yes.
Okay.
So tenacicine, it's unknown. Them can't classify. Them don't know what is happening. But you know, it could be based on the argument now that if iodine is a solid and astatine is a solid, that means this one has to be a solid as well. But you know, as they continue to investigate, these things are being discovered. And if you notice, there are some unknown ones here between 57 and 71 and 89 and 103. All right. And then now, this is what they come up with thereafter, because this was discovered later. So that's why it's not included up here. So the discovery of these came, who to tell? Maybe there is something else to be discovered that nobody knows about. Right? So yeah, and as life goes on, you know, people are doing more work and more discoveries are being made. So as we get older, as we get smarter, as the use of the technology becomes more prolific, you know, we are making more discoveries, right? So when we are very old and we have our great grand, and say, oh, I was in a lab working on something because there are some scientists who received some Nobel Prize because they discovered something that no one has ever discovered. And you're like, oh, nice. Remember your great grand did a science degree in environmental studies, right? But in our time, we don't have the technology to find and to discover these stuff. Case in point, Jamaica for sure don't have the technology to go and mine or natural deposits of nickel and copper and chromium and titanium. I think we may have vanadium there as well in our exclusive economic zones within the ocean, right? And the United States and other countries up north may have the technology to do it, but for them to come to ship their technology to Jamaica and for them to reap or to mine, it wouldn't be beneficial to us. It would be beneficial to them because it's their equipment. So they may want an 80-20 or a 90-10 sort of percentage. And it's not going to benefit us. It's really not going to benefit us at all. So we don't have the technology to go down, and this is deep ocean. And I don't care how good I swim, I ain't going down there because the moment me see something don't look like me go on run. I mean, no me can run in the water. So some people have some nice jobs, and I'm proud of them. I'm very proud of them. For example, with my training, I could go and work on an oil rig, as most of my compatriots from Trinidad would have studied and would have gone back to work on their rigs. And got an offer once, paid pretty good money, but when I thought about it, I was like, negative. This is not how God expected me to die. So it's not going to happen. But these people work out at sea. They work 24 hours. The intensity, and it is dangerous because sometimes they do deep sea drilling, and they are drilling through the seawall, going down to find oil and making structures, right? You wonder how, for example, the causeway here was built, and it's lots of environmental engineering, right? So Mikey said to me earlier, said, sir, you're going into the engineering part of the stuff and you're destroying the environment. We have environmental engineers. So while we are engineering the stuff, we are also taking care of the environment or taking the environment into consideration. So this is something that you can look into now for your environmental engineering course that you're doing, how it is that we are going to be mitigating against some stuff. Because the truth is, we need some connection from across the causeway, because people need for move from one place to the next. But how are we going to do it? We had to go down there and do deep sea drilling. We had to get different rods of different size, because we can't just go down and drill one big hole. Because we drill one big hole, we are going to crack it and it's not going to work. So we have to go down with different bits and drill one thing, then use a larger bit and create a casing for the smaller one that we used before. We use a larger casing for the one that we previously. So every time we go down, we use a larger casing, and we secure the small hole using a larger casing, and we support another hole. So it is that we end up getting what it is. And as we go in, we're adding, steel and cement. So at least, we're getting the strength as we go. And really and truly, we're getting into the seawall, and it not gonna move. Yes, we know we had an earthquake in the Caribbean Sea on Saturday, and these are things that the engineers, the environmental engineers, will have to go to make sure that there's nothing wrong with the foundation of the stuff. There are no cracks, because we don't want anything catastrophic to happen. So there's always going to be a job for an environmental engineer, right? And if you have the technology that you can go down, maybe you don't have to go down there. Maybe you can take a boat and go to the base of the bridge, and you can send something down, some sonar, or you can send something with a not a microscope, but a camera, and you can actually look at what is happening, and you can say, okay, this is fine. You can also send something there that you can, with the technology, measure it to see if there's any shrinkage or shifting of the stuff. So the technology is really out there to make people safe. China has done it. They're making. It's not like us going over the causeway where them have. It's just a small piece of the ocean we're going across. them have bridges that miles away in the ocean. And what it is that they do is they're using belts. They're using belts to hold the bridge in place. And these are many belts, because you think of many vehicles on that strip going at the same time, and they don't put any structure in the ocean per se. So these belts are holding its structure up from other areas. Go and research it and see it, and then come back and we can have a conversation on it. It's very interesting how it is that we have intertwined engineering with environment, how we've intertwined all of this now to make life so much easier. And remember, so Mikey, let us go back to what it is that you're saying. One may say, but sir, why are they going into the natural harbor to disturb it? Okay, tell me what you'd prefer, for us to do something like that, or for people now not able to go across the causeway, but now to drive Mandela and go about their business. One, you're using more crude. One, you're sending more exhaust in the atmosphere. So when people can take a shorter commute, the exhaust is going to be far less. So you're going to have less damage to the environment. So you're weighing which of your evils is worse. I don't know if this is the point I'm making. Are you?
Yeah, I do see the point. But
Go ahead.
there are other solutions that can minimize. All right, put it this way. Whenever you have any development, there is going to be some impact to the environment. There is absolutely no doubt.
Absolutely. However, that's why you do EIA.
Exactly. However, my thing is this. In mitigating those impacts, I would rather not introducing too much artificial and have a more natural approach, which would see the environment becoming more resilient and recovering fast.
I agree with you, but what I want to ask you and the others to participate in this conversation too, how then are you going to be using natural stuff to get to build infrastructure? Because you're talking about development, right?
So using the causeway as an example, when they were building, I remember they were dredging and they were dumping and they were removing all that mangrove that was there. The issue that I had at the time as a young environmentalist, wondering why are these people destroying all of this nice, pretty trees? The replanting efforts or the identification of a suitable site to replant or to improve upon was done later on. They barely started to plant at the edge of what they removed, and what they had replanted is nowhere compared to what was removed.
Because it takes years, Mikey. Because it's what you're talking about. I agree with you, because they had to, it's like our policymakers that I spoke about earlier, in terms of them not having to put that artificial groin to prevent further erosion. It was the best solution, but they removed mangroves so that they can build and connect Port Royal to Kingston. Because remember, if you look at our history now, or if you look at the geography of it, you had a breakaway of some points. So therefore, in order to reconnect, they had to go and create amend, so to speak, to reconnect. And in creating that mend, there is always, as you say, going to be some impact analysis that that must be done. And that's why you had to do EIA. a critical course, because what you are now going to do now is to mitigate the environmental impact. True or false?
True.
Yeah.
You know what a better solution would have been for the Palisades?
Mm-hmm.
By simply just planting some wetland grass. They grow very fast and they are able to become stable in lesser time than those rocks need to be set, and would have not caused an impact for another. Because remember, you know, for those rocks to be there, you have to disturb another ecosystem to get those rocks. Because I remember when those rocks were being moved, and St. Elizabeth coming up Fir Tree Hill, you have these trucks with two big boulders and it's coming from St. Elizabeth. So you know that they have to be served somewhere else. But my sense, if they planted that here with the grass would help in terms of stabilizing the shoreline and even breaking those waves that are coming in. And the grass would have grown to a significant height. That would offer some cushion when you had the storm surges and things coming in.
So let me ask you a question. So don't you think that all of those suggestions were considered?
They were considered, but
They were
guess
considered.
what? Let me tell you
Go
something
ahead.
about Jamaican politics. The best option is not always chosen because a politician wants to remain in office, and the only way he can remain in office is if he can give a certain amount of work for a certain amount of people. And
we know this. We know this. But in all fairness, though, in all fairness to the planners, if you go back to Palisades and you look along that side, it's not the whole stretch that those boulders are in. There's a cutoff because a section of the Palisades is filled with evergreens, with these mangroves, right?
Yep.
So it's just the area that proved most vulnerable, that they had to introduce something artificial to mitigate other things from happening. That's what has happened.
It would have been way cheaper, in my opinion, to plant the seed.
And I hear you, but I also say to you, I hear you and I agree with you, but I will also say to you that those options were considered. Go and research it. Those options.
I know that. I remember Omar did I make up noise about it. I remember.
Yeah, man, those options were considered, But I'm saying to you, based on what was happening, because people are saying, who live in Harborview, are saying, yo, they might talk about tsunami in their Jamaica a lie, because we saw it happen. The water came up here, so this was the height of the water. We stayed in our houses and were looking across over to Port Royal, and we saw the tsunami. I remember and this was years ago, I was studying. Matter of fact, forgive me, but you're doing a course like this, you pray to God that you have a hurricane, because you want to go to Sapphire Hills map to, and you want to map it and map the stuff. So when I was going to school, we pray for one hurricane coming. So when the hurricane coming up, hello, we were the most excited set of students on campus. We were every minute we have our pencils and we're listening to the stuff. We're looking at our latitude, longitude, and we had a professor. He died recently, Rafi Ahmad. And when Rafi come and say, "Come take out the stuff," this was, what course was it? Hazard management, I think it was. And we had to take out our stuff. We had to map. We had to map the stuff, the track, the hurricane, and then now pretend as if we're giving advisory. So, people who are doing meteorology they have to do some environmental and geological courses, because they will need to know how to do XYZ. So we're very excited. So this was one of the things that caught my attention, because every textbook I read, tsunami not in Jamaica, but the people them say tsunami come. And this is how we write our geological past. We have to go and interview them people of long time, who live in our community long time, and them say, no, one volcano that come right here, so because my grandmother did tell me, and they know when you go there and you look, you say, but hold on, there is an intrusion that is taking place because the minerals that we find right here, so are not minerals that are surface. These are minerals that are beneath the earth. So we can use the geological mapping and say, yo, it is true. Jamaica had a volcanic past, right? And we have the exposure right out there in Clarendon. We can't go and look at it.
Well, sure. I'm gonna add something else to the whole argument. All right.
Mm-hmm.
So at the time, the powers that be say, hey, we have to save the Palestinians because of the on the road to the airport, in and out, all of that.
Mm-hmm.
If you are able to like use ArcGIS, yeah,
Mm-hmm.
and track all the storms that passes and
Mm-hmm.
impact that area of the
Mm-hmm.
Palestinians, and then look northeast or
Mm-hmm.
southeast, whichever direction, back to Harbor View, Bull Bay, and
Mm-hmm.
look at the type of flooding that have been occurring since that wall has been implemented,
Mm-hmm.
and and see if the the if it's still a good idea. Because one, the because of that wall, the Bull Bay Harbor View thoroughfare has been battered more than usual since
Mm-hmm.
it has been in place. And more flooding along that corridor has been happening.
And you know why? You know why? I went that side about a month ago.
Mhm.
And I sat in that bus, the school bus, because it was a school function. And I sat in that bus and I got really very upset. Really, really upset. Because the natural runoff, the gullies, the rivers, some of
Yeah,
those areas were blocked off.
block. Yeah,
I am going to tell you, when that water ready to take back its course, hell and powder house down there, so
yeah, man. So
right.
the
So
policy, as I say, now, sir, the decision for majority of projects.
no, we
But,
know we know we know this. We know this. As I don't know if I told you. Matter of fact, I was teaching the geology at that time because was it geology? Yeah, man, I was teaching the geology at that time. I went down to Marina Villa. Um, I was teaching one. I was teaching you guys maybe. I think it was geology. We did geology in the summer, don't?
yeah, yeah, yeah.
Right. I was teaching geology in the summer when I was on a little staycation. I went down to Marina Villa, and I remember one Sunday morning after church, I was just walking along the beach and I was just reflecting and just, having a little one-on-one connection. And as I walked, I saw some fan corals. And I bent down and I took it up and I said, but I don't understand. This is a fan coral. Why is it that a coral is here? And then I started thinking a lot of things and I said, oh, maybe, there's a dead coral somewhere down there, a reef down there, and the waves are carrying in the fan corals. And I said, but how so? Anyhow, I took up that little coral, fan coral, and I had it in my hand, and I was like, wow, boy, this pretty, man. And then as I walked further out, I'm seeing the fan coral now in its entirety coming from the base. And then I stood up. When I looked behind me, the people them look like a pin to show you how far out I gone. And then I said to myself, idiot. Then suppose no something come out upon you or whatever. How you going to manage? And then, you know, I was a little perplexed and I got a little upset because I'm saying, why am I seeing so many fan corals? And then I stood up and I went closer to the shore. And I was in rubber slippers, Crocs. So I could walk, I could step in the water. And I stood up and I said, but why is it that you have these corals coming up? I said, this don't make any sense. This does not make any sense. And then, I looked down And when I looked down, I recognized that I was standing on a coral reef. And then I got even more upset. I was literally standing on a coral reef, and I said, that's why the fan corals are there. And I'm saying, coral reefs don't come in shallow end. And when I went back and I sat down and I went back, I was teaching geology at the time. I remember now. I met one of my, not batchmates, but schoolmates. He was in the same year with Waldo, I think. No, it wasn't Waldo, but he knows Waldo because we were talking and we're making connections. And he's in policy. And I said to him, yo, this was my experience and I am very upset. He says, but where we are now in the pool was ocean. And they dumped all of that area to build that massive structure. And let me ask a question. You think me would I spend my money and go over there but me go buy no housing? I wouldn't do that. I wouldn't do that. Because so when I said to him that I'm saying, but hold on, the whole stretch down there, so it's dump the ocean in order to build these massive housing schemes, these massive housing, and these housing is like 500,000 US dollars for one. It's not penny farthing for them. It's not penny farthing, right? So yes, I agree. You know, we damage the environment, and but sometimes what we have to do is use our engineering or environmental engineering to mitigate further damage to the environment, so it is that we can preserve what we have left. All right. So
Sir,
now,
but one
go
one
ahead.
one 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 thing I realized, sir, like
Mm-hmm.
going through the course, I
Mm-hmm.
realized that some of the conversations that we have about daily life, for example, what you just mentioned about the housing scheme,
Mm-hmm.
we as environmentalists, it seems like it's almost a losing battle because how can you prevent something like that? Especially like um
Mm-hmm.
based off of what Michael said, as
Mm-hmm.
we all know, politicians and high personnel, they practically have the say. They're not going to want to lose their income. So how
Mm-hmm.
can we as environmental officers, how can we go against that? Because of course we're going to get a fight.
And Paz, right about now, you're touching a sore point for me because it is unfortunate that politics is so dirty that if I know I couldn't get into policy, I know I couldn't get into policy because I am not going to see something that is wrong, and I believe God has given me a voice, and I'm going to say, but this is not good for the environment. I hear you. I hear you talk about lawsuits, but guess what? Even before we reach the lawsuit path, Mikey, um, dollars speak, and sometimes these people will set people out to muzzle you. And I don't want to say that they will hurt you because I really can't substantiate it, but things can happen because you are now going to be seen as a hindrance. And sometimes when these EIAs are done and you say that, boy, yo, it shouldn't happen. Oh no, we're fine because we're going to do this and we're going to do that, and then bam, a hazard takes place because you did not adhere to the things that we advise you against. Um, money run, money run, and money talk. Because if I say a development, and if it's my signature will give the authentication of that development, I want you to tell me, um, and this is how corruption can be introduced to a system. So Mikey has money. Mikey gets a piece of land. Mikey wants to build a hotel. Mikey has his money. I'm not even questioning where Mikey gets his money from. I may very well know that it is dirty money, but Mikey comes and puts in a bid and say, yo, big boss, say, remember you used to teach me a long time, and I say, yeah, you say the plan. How would you see yourself living in a penthouse, a 5-bedroom penthouse, free of cost? And then I say, whoa, look how me did apply to NHD, I can't get no loan. And here goes one of my students who is promising me a penthouse. I say, yeah, man. I say, yeah, man, so I see a piece of land I want for the time. So, but boy, Mike, the impact analysis don't look good here, so, because the soil type is not good, and what we'll have to do now is to dump and compact, and we're going to be damaging the environment, and aquatic plants and animals now will have to be uprooted, migrated, and I give you all. I said, no, something else can happen, and then no, I have to go to Paz, who is my supervisor, and then I forgot Paz and said, boy, Paz, this is a situation, support and so on, and then Paz said, well, he said, don't worry about it, man. We can be neighbors because you can get a penthouse out of it too. Paz said, yeah. And then of course, so Carl, she go on for her syrup. So Carl go say,
Sir, me not do no more experiments. Me not doing nothing more. Cause you got trouble me with it.
Carl, there is a member of my family. One day I was driving, and this is real story. And sorry to break the session, real story. And person said to me, then let me ask you, Carol really loves syrup for true? We said, Jesus, Father. I said, who is Carol? The same one in the class that always leave the class to go and drink syrup. I was like, okay. So, Carol, your secret is out there. All right? Just to say. But let us go back to that now. So when Carol goes now and Paz has to go to the top now, Carol is at the top. And Carol says, well, say, this is not right, And Paz say, you're the plan. Boss lady, a 2 penthouse here getting, because what is going to be built is going to be enough to, and then Carl say, 2 penthouse? Oh, yeah, man. And then now, as I go down the chain, me the small man down there, So me have to answer to Paz and then to Carol. So when me go get, it's just going to be a cut out of the bucket. Paz going to get a cut more because me I forgot to just talk to him about that, but Carla will get a big thing, and then the documents are signed off, and then you see this massive construction that is taking place. And when the construction takes place, a whole lot of impacts taking place, because what happened is that the sewage is not improved, the water line not improved. There's a strain on the electricity from JPS. This is being built, but guess what? You don't have the infrastructure around to no supermarkets, not their own, no market area. It's what I mean. So yeah, it's a ripple effect that we're talking about. So yes, I agree with you, Mikey. But as I said to you also, that we have to take some risk. When we see something going bad, we have to use our environmental engineering techniques now to mitigate, because if we don't mitigate, chances are it's going to get out of hand, and it is going to be irreparable at some point in time. It's going to be irreparable at some point in time. All right. So we got to there because we're talking about some of these elements that occur in nature, and we got there because we're talking about the different states of our group 7 elements, or fluorine, chlorine, bromine, iodine. And of course, we spoke a little bit about acetylene because we know that it changes from gas to gas, then to liquid, and then of course our iodine is going to be a solid. And if our iodine is solid, it means then that acetylene is going to be solid as well. So those are what it is that we're going to be looking at. What you are going to be doing for homework, as I said before, I'm going to finalize it a little bit more in terms of you doing this, and this is going to be a graded piece. As I said before, just make sure that you adhere to completing these assigned tasks. This is your final semester. We don't want no mishap in the final semester. This is going to be the roughest semester for you, because you can believe that everybody giving you homework and it's going to be everything done on you, but it's going to be a rough semester. So just make sure that you pace yourselves as you go along. All right. In about 10 minutes time, by the way, are there any questions? Stop sharing here. Any questions?
No, sir.
No, sir.
All right. So I'm going to now just quickly look at we did some formula writing. No, structures rather. What I want us to look at now is a little bit of our formula writing. So remember, ouch, we did
You're not sharing, you know.
I know, I just stopped sharing a while ago to find another document. So I'll share this document now that so last time around we looked at our calcium chloride, and we were able to draw the structure of calcium chloride. Is calcium chloride an ionic bond or a covalent bond?
Ionic.
Very good. You said ionic or ionic?
Ionic.
Okay. Potassium chloride, is it ionic or covalent?
Covalent.
If I clap, you see? If I clap, you see? If I clap, you see? You see, oh, it's so much time you have to threaten you? No. Remember, potassium is a metal.
Oy.
Remember, potassium is a metal, all right?
Yeah, the metal normally right first.
Right, and the metal is written first, right? So once it is a metal, the metal plus along with the non-metal will give you the ionic. Metallic is metal, and covalent is two non-metals. So sodium sulfate, it's going to be something that is ionic because sodium is a metal, and the sulfate SO4 is going to be that. But what I want to show you though, pretty quickly, is let us look at, for example, our sodium sulfate. The sodium ion, remember, it is Na plus. The sodium ion, sodium is going to give up one electron. And then we're going to have the SO4 2 minus ion. So this is a cation. And this is our anion. And that's our anion. So what is happening is, if you look at sodium and say this is going to be a +1, which is from up here, so, and the sulfate is going to be a 2 minus. If you do the cross multiplication like this is now going to become Na2 SO4, and this is going to be to 1. But would you write 1? You write 1x or just write x?
X.
Right. So I wouldn't put anything there. So that's how I get the formula for sodium sulfate to be Na2SO4. Let us go back to the one that we looked at last class, calcium chloride. So calcium has a 2 plus charge. How you know that, sir? The electronic configuration is 2,8,8,2. These are my valence electrons. They will give up. And the chlorine is 7, 2,8,7. Chlorine now needs 1 electron. So therefore, I have 2 to give up. You remember, chlorine can't just give up 1. Chlorine has to give up those valence electrons. Remember the conversation we're having, Karel, Mikey?
Yes, sir.
Right, them can't just give up. So what we're looking at the aluminum oxide. Them can't just give up something like so. So them have to go give up both of them. So chlorine then say, yo, so one me want. And chlorine then say, yo, it's all right, man. Me have one chlorine, brother. And that's why chlorine now is going to have this +1 charge, because it can only take 1. When I do this sort of cross multiplication, I'm going to have Ca, it's 1. I don't need to put the subscript 1 there. and then Cl2. I don't need to put the 1. So all we're going to just write is CaCl2 because I'm going to need 2 chlorine in order to get that. So that's why my chlorine, my calcium chloride rather, is going to be this. We looked at I just looked at one more. We looked at aluminum something the last time. Oh, see there, the aluminum oxide. If the aluminum oxide, aluminum is 13, 2,8,3. It means it has a 3 plus charge. You see why it is important for you to know the homework that I'm giving you is not just to get a grade for you, it's for you to know the first 20 elements of the periodic table. Because just like when I say aluminum, I know aluminum is 13. And I know that the electronic configuration of aluminum is going to be 2,8,3. And I also know that 3 electrons in this valence shell will be the ones that are going to react. It means that aluminum is going to be giving up those 3 electrons. All right. And then my oxygen now is going to be 2,6. They need 2 of that. So it's going to be 2 minus. Why 2 minus? Because I need 2 more electrons. It is accepting 2 electrons. So when they accept, it becomes negative. Remember that. Accept is negative. When they donate, it's positive. So what I'm saying to you, aluminum is donating 3 electrons, so it's going to be positive. Oxygen is accepting 2 electrons, it's going to be negative. So what I'm saying is, because oxygen needs to accept 2 electrons to make it a stable octet, it's going to have a 2 minus charge. Aluminum is going to be giving up 3 electrons in order for it to become stable. So it means because it is donating those 3 electrons, it's going to be positively charged. All you have to do is to do your cross multiplication like so. So this number becomes Al2O3. Any questions?
No, sir. I'm glad they do that because I finally understand this method.
Yeah.
We're happy to show that.
Yeah, man. So
It's shorter and easier.
it is, and that was part of the plan. But also I had to show you the covalent bonding first, and then to come down so you can see exactly what is happening. Because we wouldn't want you, so in an exam, we wouldn't want you to go and have to draw the structure in order to see what is happening here. This is a quick shortcut method. All right. What I'm going to ask you to do for me is to write the formula of aluminum fluoride. Aluminum fluoride. Aluminum fluoride. Remember, fluorine, chlorine, bromine, iodine. What group are they in? We just talked about it. Hello, somebody. What group are they in?
Sir, solid.
No. What group of the periodic table are they in?
6?
No.
No, 7.
7, you mean? That?
Group 7. Because them come off the 7. Chlorine come off the oxygen.
Because they are in group 7, how many electrons in this outer shell?
In fluorine?
In fluorine, yeah. How many electrons in this outer shell?
2, 7.
Yeah, but you don't have to do that. If you know that they're in group 7, that means how many electrons in this outer shell?
7. Yes,
7.
7.
Right. So how many electrons it need in order for it to be stable?
1.
So what's the charge of fluorine?
Chlorine is.
Sorry, fluorine.
Chlorine is
Positive.
17.
No, man. Think about it, no, man. How many electrons in the outer shell for fluorine?
1. So
No.
yeah, say that means.
How many
7,
electrons?
sorry,
7. So there are 7
Yeah.
electrons in this outer shell. how many electrons it need on in order for it to be stable?
1.
It would need one as well.
1. Will it be accepting or giving up 1?
Accepting.
So therefore, is it positive or negative?
Negative.
Excellent. Excellent. Some syrup sugar drink a while ago, you know. Excellent. Excellent. Very good, Karel. Talk to me now. Aluminum, what group is it in? How many electrons it has in its outer shell? You need to know the periodic table. Paz, how many electrons aluminum has it in its outer shell?
I think that's 3. Sure, 3. 3.
Yeah, but you see, I don't understand you guys, you know. I just did it right here, so.
Yeah.
I just did it right here, so. See it right here, so. And it is on the screen. So aluminum is 13. It's 13th element in the periodic table. 2, 8, 3. So the valence electron will be 3. So what group is it in?
Group 3.
Group 3. Will it give up 3 electrons or will it accept?
It will be easier to give up.
Good. And because it's giving up 3 electrons, is it positive or negative?
It is
Positive.
Positive. Once you're
Yes,
giving up, you're positive. Once you're accepting, you're negative. So what's the formula now for aluminum fluoride?
Fluoride or chloride?
Fluoride.
ALF3.
Harold, do you agree with that? Gone, she gone, you know. Paz, you agree with that?
Yes, sir.
Yes. So ALF3 will be correct.
Right? Oh.
No, good. Mhm.
All right, will be correct. All right. On today's what? Today's the first class of the week, right?
Tuesday. Yeah. Mhm.
Yeah, but graduation Thursday for no class.
All right.
Oh,
So,
yeah.
that is going to be a little tricky now. So yes, our class on Thursday would have started at 5 o'clock, don't?
Yes.
Yeah.
So I'm sure 5 o'clock I'll still be at the conference center for graduation. I intended to do some formula writing for you or with you. So what I'm going to do is I'm going to give you the piece of work that I'm doing here. I'm going to be sending out as work for Thursday's class that I'm going to ask that you complete, submit, so that I can look at it and give back.
Sir, 1 minute. You can just repeat what you said a while ago, please.
It is gone, don't?
Sir, never
But we are
Go
talking.
drink that syrup.
Yeah, but we are talking. I know answer. We are asking if you agree with ALF3. I know answer.
Oh, yes, sir, I agree with it.
All right.
Mhm.
No, what I'm saying to you, Carol, is that on Thursday we have graduation.
Oh, yes, sir.
Right. So I do have a choice. I have to be there. So there's going to be no class, but I'm going to be giving you work to do. No, I'm going to give. I I should be able to. Yeah, I'm going to give you the work. I'm not going to promise you that I can give you the work tomorrow, but because I've started writing it as you've seen it. But I'm just going to finalize my thought process, and then you can do it in your class time, submit it. The only challenge for me this semester, guys, is that I am doing multiple courses, like 5 different courses. So when I said to you, say, yo, I know it's not a lot of you, so therefore you guys will be preferentially treated in terms of when I give you the stuff, yours is going to be so much easier to mark as opposed to the 20 and the 30 ones that come in our class. So if I said to you, Mikey, I want the work today, and you give me the work 3 days later, that not gonna mark because I'm gonna have a class of 30 odd students now to go mark. So we can't put on for them one and then go mark here. So when I said to you that the work's supposed to come in at a certain time, it has to come in at a certain time because I have to pace myself 5 different courses this semester. And I have to pace myself so that I can, commit and do the stuff that I'm supposed to be doing with you. All right. Any questions?
Yeah, so we're not for login Thursday.
No, unless no,
Mm.
no, you don't have to log in on Thursday.
No, normally graduation day, them not send out no link other than
In
the
other June?
Yeah,
graduation.
they don't say that. Right. Yeah, because the classes will be suspended at 12 o'clock, them say.
Yeah.
But what I would want to do though is I'm gonna give you some set of reading so that when we come to class, because it's like how we're doing structures now and you have to write something. When the reading part of it come up now, we're just gonna be it's lots of reading and getting the information in your head so that when you go you can talk about it. So like all for example, I could give a question. It is reported that Duns River Falls is in crisis. As an environmentalist, explain in detail how it is that you would mitigate against so forth and so on. So you have to understand the intricacies of what is happening in the little scenario that they're going to give you, and you're going to put on your environmental cap. So there's going to be a compulsory question on the exam paper, and for 30 marks, no, I think it's 30 marks, compulsory question, and then and then you can choose any other question from question 2, 3, 4. Right? That compulsory question now is a question that is you, the environmentalist, that is speaking to me, the lecturer. So I want when you go there, if it is 4 points that we're going to talk about, you talk in detail about those 4 points. And you don't have to worry about it because we will speak about things like pollution for the hydrosphere, pollution for the atmosphere, pollution for the mesosphere. So we look at pollution, right? For argument's sake. And if you get a question on pollution, you should be able to answer. The question could come in the hydrosphere, could come in the lithosphere, could come the atmosphere. Wherever it is, you will have enough information on pollution. You'll have to think like an environmentalist. And remember, what you're talking about is something that is plausible. So don't come tell me, say, you can fry chicken there that not come in, that don't have nothing to do with the stuff, don't mention it. All right. So it's not going to be difficult. It's a fun course. After we're under the last part of this, I know exactly what I'm going to give it to read. We're on the last part of this, and then the last part of it now, I am going to give you something to read for me, and then now we can have conversations when next we come to class. All right, so big up on yourself, study, guys. You have to study. If you don't study, you're not going to make it. It's a dog eat dog world, and you have to have it on piece of paper. You can't just gonna say, yo, I'm working in this field for 20 years, I have it locked. Okay, no problem. HR needs to see a copy of your certification. So never finish a program. I'm sorry, sir, you can't be employed. So just stick to it, get a little piece of paper, and move on. All right, guys, thanks for coming out. You did well.
All right, sir. So that means
Okay,
next
sir.
week,
Good night.
Yeah,
next
man,
week
good night.
Tuesday. All right.
Next Tuesday, yeah. By the way, Okay, Mikey, you seen Karel, you seen the recordings?
On the YouTube channel,
Yeah.
let me double check right now. I was supposed to ask if you were posting them, you know.
I have been posting them. But I don't
Okay.
maybe you and Paz may know about it, but I don't think Karel knows about it. Karel?
No, sir, I didn't know about it.
Johnny, can I go on? Let me share the YouTube link with you, Karel, so that you
And
can
you put us a pre-calculus, calculus 2, semester 2, 2025. Hold on, let me go inside. Oh yeah, yep, they're there. Chemistry and the environment, semester 2. You post 5 days, 1 viewer. Oh, no. Yeah, all of they are there. Yep.
yeah, man.
Recordings are there.
Right. So Karel, see the link there. Mike and Paz have it because they did statistics with me.
Yeah. If his name come up there.
So do me a favor, just subscribe to the channel so at least when I post the recordings, you can be notified that the new recordings are there.
Okay, sir.
All right, big up on yourself later.
Okay,
Yes,
later,
sir.
sir.
Mhm.